In this video, we are going to focus on modulus inequalities. Now, this is one of those areas where students face a lot of problem. So, I am going to make it really simple by dividing into problem types and giving you real strategies that you can use to solve problems. I promise you that if you watch this video on modulus inequalities, there might not be a single question where you will find it difficult to apply these concepts. If you haven't watched my earlier videos, it is highly recommendable you go and watch them. But if you have got the amount of knowledge that is required to do this, go ahead and let us start with it. Let us first start with a basic trick that can help us solve this type 6, which is based on basic technique of solving inequations. See, there could be two scenarios. One is mod of x is smaller than 2 kind of a scenario, and another could be mod of x greater than 2. Let us understand what happens in both of these scenarios. If I want to solve the first one, the core idea would be to take two cases. So first I will consider my case 1. My case 1 is if I take values of x smaller than 0, that in that scenario modulus will open with a negative sign. So minus x would be smaller than 2. Or if I take minus sign on the other side, middle sign flips and x would be greater than minus 2. Now, in order to get the final answer, I will have to take the intersection of this with the condition given above. So, what we are saying is either x would be smaller than 0, it should be smaller than 0, or it should be greater than minus 2, and it should be greater, not or. You can see that your common solution lies between minus 2 and 0. So, this is what we get from the first part. If I consider another case, that is case 2. In my case 2, I will take the values of x greater than or equal to 0, and hence the modulus sign opens with a positive sign, and now again we will take intersection of both of these conditions on the number line. So, what we are saying is it should be greater than or equal to 0, but smaller than 2, and as a result we have got the values between 0 and 2. Now, either case 1 or case 2 can happen. So, ultimately we will have to take union of both of these cases. So, you can see that the answer to this question comes out to be between. So, my final solution becomes x belongs to minus 2 to 2, because we have taken union of both the cases. Okay. Now, what we can do directly, and if I want to solve this question, we can have a shortcut around it. That shortcut will go like this. So, if something like this is given, you can directly write it between minus 2 and 2. This quantity should be positive, that is important. So, this becomes a shortcut. So, from directly, instead of doing this case 1, case 2 and then solution, will directly jump onto this step and write the answer. Let us see what happens in this next case. So, in this next case, again we can consider my case 1, which is my primary interpretation technique. I will take values of x smaller than 0. Modulus opens with a negative sign. If I take minus sign on the other side, the middle sign flips, and now I will take intersection of both of these. So, we are saying smaller than 0, and the second condition says smaller than minus 2 also. If I take intersection, my answer becomes all the values of x is smaller than minus 2, or minus infinity to minus 2. Both the signs are open. Again, I will have to consider case 2. In my case 2, I will take values of x greater than or equal to 0, like I did earlier. And now, when I do so, modulus opens with a positive sign, x is greater than 2. Now, again, if I take intersection, the first says x is greater than or equal to 0. Second says x is greater than 2. We take the common solution. So, answer becomes the same, x is greater than 2, or we can write this as 2 to infinity. Both of them. If I want to write my final solution, I will take union of both of these, and my answer becomes minus infinity to minus 2. So, always we will take union for whatever comes in terms of cases. Once you have got this, now we can summarize this. So, instead of doing this, what I could do is basically I can do this quite fast. Whenever this is given to me, I can write this as either x would be smaller than minus 2, or x would be greater than 2. So, this becomes a shortcut that we can directly go from here to it. Now, let us see. I have put this in the form of a table so that it is again very clear to you. But I hope you have got the formula. This is the basic technique. If you want to see a very detailed version, this is given here. Now let us see how to apply it in this question. So what I am saying is we can still make the cases, which remains the most important primary and fundamental and conceptual technique, but it takes time as well. So it would be better that if I do it without that. So here what we will do in the first step, whatever is the quantity inside the mod, psychologically you are taking it as one quantity. And if I remove the mod, I will write -2 here. I will write 2 here. This is the single most important step. After this, since there is 5, we can add 5 on both the sides. So -2 plus 5 and then 2 plus 5. And the answer of x lies between 3 and 7. So answer of this question becomes 3 to 7 open on both the sides. You can see that this shortcut helps us save a lot of time and energy. Now let us move to the next one. So if I do this next one, you can see greater than equal to sign is there. So in the first step, whatever is inside the mod, I will consider that as one quantity. So either this could be smaller than -7 or x plus 3 could be greater than +7. If I solve the first one, x would be smaller than -10 or x would be greater than 4. That would mean my answer will become -infinity to -10 union 4 to infinity. Very simple, very elementary. I hope you are getting the idea. Now, if I move towards more complex question that looks more complex, at least like this question, so you can pause the video, you can try it out. But now again, you can take in the first step, let us first simplify. You can write it like this. This 3 by 5 we can take out. We can put a modulus sign here. And then we can take it on the other side. Since it is a positive quantity, it will become 5. Again, if I remove the modulus sign, that would be -5 on one side and +5 on another side. If I subtract minus from all the 3 parts, it becomes -6. This becomes 4. So my answer becomes -6 to 4. You can see that this idea is fundamentally the key in solving all such kind of questions. Let us look into this question now. I think this you should be able to handle. In case you are not, you should pause the video and again see what I am doing. So first step should be, see, most of the times I will want the coefficient of x to be positive. So in the first step, it would be better if we can write it like this. It is not going to make any difference because mod of -x is equal to mod of x. Once you have got this, now this can have two interpretations. One, it could be smaller than equal to -1 or 2x minus 5 could be greater than or equal to 11. If I solve the first part, it becomes -6 or x is smaller than equal to -3. Or if I do the second part, 2x is greater than equal to 16, x is greater than equal to 8. My answer becomes -infinity to -3, -3 is included, union 8 to infinity. 8 is again included. Moving forward, next type of question that is based on type 7, that is based on interpretation to solve questions. Let us look into this first question that is based on this technique. In this question, we have to solve this inequality, but let us first reorganize all the terms. As I told you that I don't want negative signs. I don't like negative signs inside the mod in front of x. So let us first neutralize that. Then what you have is x plus 1 and then minus of mod of x plus 1. Now, we will have to interpret this because there are too many mods to apply the condition that we just learned or the technique that we just learned. So, we will have to make cases. How to make cases? The technique is very simple. Whatever is inside, put that equal to 0. Whatever is inside this mod, let us also put that equal to 0. So, if you have got the case 1 smaller than -1, case 2 between -1 and 3 by 2 and case 3 greater than 3 by 2. Now, let us look into this. Let us consider case 1 first. That is values of x is smaller than -1. If I consider this, you will see that all the moduluses will open with a negative sign. Let us do that. So what we have got is a very simple inequality where x will generally cancel out. So 5 is greater than 0. That would mean it will be acceptable for all the values in this interval. So the answer of first one becomes -infinity to -1 because whatever I put in this duration will satisfy this inequation because this is kind of an identity. So all these values are acceptable. Now let us go to case 2. Case 2 says that you have to consider values between -1 and 3/2. Let us see what happens here. You can see the first part will still open with a negative sign, but the next one will open now with a positive sign. And as a result, these two parts will get cancelled out. And 2x minus 3, if I take minus sign, this middle sign will get flipped and x would be smaller than 3. So if I figure out the values here in this interval, what we are getting, the original interval says that between -1 and 3/2. Endpoints are included. Wherein when I have solved, it is saying smaller than 3/2. Means all the values in this interval will come except 3/2. 3/2 will not come. This is my answer. Now let us go to the last case, that is case 3. So in this case 3, we need to consider for values of x greater than 3/2. So if I put this, all the signs will open with positive sign. All the moduluses open with a positive sign. You can see that this term again cancels out. X comes out to be greater than 3/2. You can see that both of these conditions are same. So all the points in this interval would be acceptable. So this is my answer. If I take, what would be the final step? Final step, the real solution would be union. We take intersection in our case and then union of all the intersections, all the cases. So my answer becomes union answer of the first part, union answer of the next part, then union answer of the third part. And or this could be written as nothing but only one number is not coming out of the whole real number, that is. So this becomes my answer. Important thing to notice here, what are we doing as a process? First step is to make cases. When you are solving cases, take intersection in a case, and third, finally take union of all the cases. This is important. If you follow these 3 simple steps, you will be able to get all such questions correct. In this next question, still we can use our 3 steps, but it would be smarter to go one step behind and interpret modulus, because there is only one modulus. So I can now go and take cases that I used to. So whatever is inside the mod, in my first case I am considering that smaller than 0. And now I will solve. So if I take the modulus, it will open with a negative sign. This happens. Plus x square minus 2 is greater than or equal to 0. If I simplify this, x square will get cancelled out. What will remain is minus 3x minus 2 is greater than or equal to 0. Or 3x would be plus 2 would be smaller than or equal to 0. X is smaller than or equal to minus 2/3. This is what we are getting from here, but this is not the answer for this case. I will have to take intersection with this part also. Now this, if I solve, this is x into x plus 3 is smaller than 0. That if solved using VV curve method, let us see what do we get. I will get minus 3, I will get 0. So we are looking of values between this negative part, these values. So now let us take final solution. So I will have to take intersection of both of these things that I have got. So first one says that between minus 3 and 0. The second one says that if you have minus 2/3. These are the important, let them put it on the number line. Smaller than or equal to minus 2/3. And then another one says that between minus 3 and 0. So this is my intersection. So answer for the first part becomes minus 3 to minus 2/3. Minus 3 is open, 2/3 can be used. This is my first part. Once you have understood this, let us move towards the next one, case 2. So in my case 2, let us see what happens. In case 2, we will consider the other case, that is x square plus 3x would be greater than 0. Now you can again solve this, but we have already got from here. Now in this case, if you solve this, your answer would be either smaller than minus 3, equal to minus 3, or it would be greater than 0. or equal to 0. Now when we take this, the modulus will open with a positive sign, so x square plus 3x plus x square minus 2 would be greater than equal to 0, which in turn becomes 2x square plus 3x minus 2 would be greater than equal to 0. We will have to figure out the roots of this quadratic. So minus b plus minus root of b square minus that will become plus 4a and c by 2a. So it becomes minus 3 plus minus 5 by 4. If I take plus sign, the answer comes out to be 2 by 4 or 1 by 2. And if I take minus sign, the answer comes out to be minus 8 by 4 or minus 2. So what we can do is, now again we can factorize this as 2 into x minus 1 by 2 into x plus 2, and then we can apply wavy curve method. So in this part, if you apply wavy curve, this is how the curve going to look like. So minus 2, 1 by 2. Both of these points are included and we are looking for non-negative values. So answer becomes minus infinity to minus 2. Now what we will do is we will take the intersection of this answer with the original answer. The original answer was minus 3 to 0. Values greater than 0 is smaller than minus. What we have got with this is another point minus 2 and 1 by 2. We are looking for values smaller than or equal to this and greater than or equal to 1 by 2. So our common intersection we have got comes out to be, the answer of this part comes out to be from minus infinity to minus 3. Minus 3 is included. Union 1 by 2 to infinity, 1 by 2. Now comes the third and the most important part, that is union of both the answers. This will give us our final answer. Answer for the first part was minus 3 to minus 2 by 3. So we will take intersection. So minus infinity to minus 3. Then union, this part will come minus 3 to minus 2 by 3. And once we have done that, comes the last part that we have written on the other side, union 1 by 2 to infinity. So again we have followed the same rule, but since there was one modulus, there was no need to take the number line concept. Once you have done this, let us move to the next type of question where there is a modulus on one side, modulus on another side, and we are talking about inequality. As a general rule, whenever on the side of inequality, if there are positive quantities, it is totally possible to square them up to solve them. This is a general rule that we can follow. Here, same thing is there, so we will square it up to solve. Let us take a question. For example, this question is given. You can see that on one side x square is there. On the other side, if I take 5x plus 6 ka mod will come. Both are positive quantities, so we can square them up. See, if they are non-positive, then we can't do it. Only in case of positive quantities you can do it. I can't emphasize that even more. So we have squared it up, and as a reason mod will go away. This we did with equations also, by the way. And now in order to solve, we'll take them on the same side. So what we have is x raised to the power 4, 5x plus 6 whole square is greater than 0. It is totally possible to factorize them and apply wavy curve method. So x square minus 5x minus 6, a minus b, and then a plus b. X square plus 5x plus 6. And now this can very easily be factorized as this will become x minus 6 into x plus 1. The second will become x plus 2 into x plus 3. Once you have done this, it is very simple to find the answer. You can draw the number line, put down the numbers, minus 3, minus 2, minus 1 and 6. Plus, minus, plus, minus, plus. You can keep it open. So my final answer becomes minus infinity to minus 3, union minus 2 to minus 1, union 6 to infinity. This is my final answer. Now again similar kind of question is given. You can pause the video, you can try and solve it. Those who have still not got it, let us see it one more time. So what we have is this modulus, we can square it up. X square plus 7x minus 13, again we'll square it up. So modulus will go away, we'll take them on the same side. So x square minus 3x minus c whole square minus x square plus 7x minus 13 whole square is greater than 0. Again a square minus b square formula we can apply. As a result, the first part, x square minus 3x minus 3 minus x square minus 7x plus 13 will come. The term multiplying will become x square minus 3x minus 3 plus x square plus 7x minus 13 is greater than 0. So this cancels out and this becomes minus 10x plus 10. The part becomes 2x square plus 4x minus 16 is greater than 0. If I take minus 10 common, becomes x minus 1. And if I take 2 common, becomes x square plus 2x minus 8 is greater than 0. If I take this minus 10 and 2 on the other side, this middle sign will get flipped. So this becomes x minus 1. We can factorize this as well. Becomes x plus 4 into x minus 2 is greater than 0. Now we can draw the wavy curve. It is a simple question after this. So what you have got is points minus 4. One point would be 1, another would be 2. A simple wavy curve would suffice. Plus, minus, plus, minus. Since there is inequality sign, all these points would be open. We are looking for values. There is a mistake that we did here. It should be smaller than 0. So now answer would be minus infinity to minus 4 union 1 to 2. This becomes my final answer. You can see that it is very simple. If you square it up, it solves itself. Now, next type of questions are the ones that are based on graph. So this technique we learned, different kinds of graphical transformation we learned, and then one very table method we learned regarding if you have multiple linear expressions in terms of mod. Now let us look into questions like that. You can see that here. Question tells us that this is given to us. So what we will do is we will take all the terms on the same side. We have x plus 1. Then we can take minus 4 also on the other side. So this function's graph we will draw. So my function in this case becomes x plus 1 modulus plus x minus 1 modulus. I have interchanged the terms. I think it is fine. Does not make a difference. Now what we will do in the next step, we will draw our table. We will take x, we will take y. Let us draw the table. So 1 point, if I put equal to 0 would be minus 1. Another mod, if equal to 0 will become plus 1. A value smaller than minus 1 is minus 2. A value greater than 1 would be 2. Let us figure out the value if I put minus 2. So minus 2, the function's value comes out to be 1, 3, 1 plus 3, minus 4, it becomes 0. If I figure out the value of the function at minus 1, the first mod becomes 0. The second becomes 2, so 2 minus 4 is minus 2. For the third part, if I put it as 1, the second mod becomes 0 to 2 minus 4, again minus 2. And for the third one, if I put 2, it becomes 3 plus 1 minus 4 becomes 0. This is what we are getting. Once you have got this, you have got all the basic elements to draw the graph. This one was minus 2, this one was 0. Now let us use all of this to draw the graph. So in the third part, let us do that. So again we will draw our x and y axis. This is x axis, this is y axis. Let us demarcate the points. So what we have is minus 2, minus 1, plus 1. Okay. And on this I can now demarcate the points. Minus 2 it becomes 0. Minus 1 it becomes minus 2. then it remains minus 2, and then at 2 again it becomes 0. So what will happen is, if I join these points, again I can join these points, and once I've joined these points, I've got my graph. Now what we want to understand is, for what values of x would this be negative? Negative would mean the graph should be below x-axis. That would mean this part. Happens for what values of x? So this will happen for these values of x. So from the graph only, in the fourth step, you can directly write the answer as x needs to lie between minus 2 and 2, or minus 2 to 2 open. As simple as that. So you have used graph to solve the inequality. After doing this, we have covered all the major problem types. Now I have given you this homework. In this homework, if you practice, you will get all the major types of questions that we have already discussed. You can practice these questions, develop even more confidence. Answers of all these questions are still given in the homework section. I hope you enjoyed this series on modulus functions. Let me know what next you want me to try it out. I am eager to help you out and make your life really simple. Write me in the comment if you want to improve something, you want more something to be done, more something to be done less. I'm here to help you out. See you in the next one. Bye.